The first one is going to be presented by Dr. Daniel Daggett. He is the Manager of Environmental Advocacy for Johnson Diversey in Racine, Wisconsin. He had collaborators on the paper included John Hamilton and Robert Israel, who are also of Johnson Diversey, as well as Stephanie Mason and Marilyn Black from Air Quality Sciences, and Marilyn Black is one of our Science Advisory Council members. The paper is entitled A Method to Evaluate the Impact of Cleaning Products and Processes on Indoor Air Quality, and looks at the questions raised by air sampling studies about the impact of IAQ on factors such as product formulation and application methodology. So if you would please welcome Dr. Daggett.
Is this on? Yeah? Can you hear me okay? Well, I want to start by thanking my co-authors, Jack Hamilton, Bob Israel, Stephanie Mason, and Marilyn Black. And then secondly, I'd like to thank CIRI for giving me the opportunity to speak today. I really feel honored to be part of such a prestigious group of speakers. I feel like I'm not worthy to be up here. But as I was sitting in the audience and thinking about, am I still on the turnip truck, or how long ago was it that I fell off the turnip truck? I was reminded of my first job out of grad school, which was working for a state health department. And I was hired as the public health toxicologist in charge of all things related to the air. And so I was pretty excited. And the first week, they said, write a bunch of fact sheets and put them out on the internet, anything relating to air quality. So I sat down to write the indoor air quality fact sheet for this state. And so I'm writing the fact sheet, and it got the sources. So sources of indoor air quality pollutants. And one of the things I remember putting down was VOCs and cleaning products. And I'm thinking about that now and reflecting back, why did I put that down? I didn't even know what a VOC was. My PhD was in mechanistic toxicology. I didn't know anything about VOCs. I didn't know anything about cleaning products. I rarely used them in grad school. So I remember now, though, it was from the EPA's website. And I said, well, if the EPA says it's true, it must be true. So I put it down there. And somewhere right now out in the nether regions of the internet, I'm sure that fact sheet is still available, that says that cleaning products cause an indoor air quality concern. So anyway, my job started in earnest then. I got the fact sheet out. And for 5 years, I did all the indoor air quality investigations for this particular state. And I don't know how many I did, but there was a lot. And there were some very interesting ones. And occasionally, we'd see some problems with cleaning products. But some of the really big ones that come to mind were a family that had 126 cats in their home. And it was actually a pretty sad story. We had to close a private home down because there was children in the home, and we removed the children from the home. The ammonia levels were so high in this home that all the metal fixtures were corroding. The fire department came in to ventilate the house and had to wear supplied air tanks to go into the basement, where the feces was up to almost a foot thick. The cats were breeding at will. They were not domestic cats. They were in the air handling system. That was a really significant indoor air quality problem that required us to remove children from a home. So that was 126 cats in a home. There was one where we had 272 chihuahuas in a home. That is just too surreal to try to describe what that scene of 272 chihuahuas just running around this house. But it's pretty amazing. And some of the other ones that come to mind, we had that involves consumer products. There was a really bad case with overuse of Dursban, chlorpyrifos, which is now a no-no with EPA, and an elderly woman who was really severely, got a severe acute poisoning from Dursban. And she called me after a week of living in this home where there was so much Dursban that the carpet was crunchy because the applicator came in without her knowing and over-applied it. And she asked me what she should do, and I said, well, get out of your house. And so every year, she would call me on that day and thank me for saving her life. I don't think I deserve the credit for it, but we also had another case where an elderly couple retired from a farmhouse and moved to their retirement home, which is a small home, and they took all their air fresheners from this big old drafty farmhouse and stuffed them into this small little tight home, and there was a lot of air freshener in the air, and we didn't have to take any air samples that day. We just said, get rid of some of this stuff. But the point I'm trying to make here is that I think this group needs to take indoor air quality and the effect of cleaning products on indoor air quality seriously, but don't lose sight of the trees, the important issues that the cleaning products have in and above just indoor air quality. We're still having problems with people not understanding labels in MSDSs because of language barriers. We still have situations where cleaning personnel are taking products home that aren't appropriate for the home, putting them into sippy cups. Children are still dying from drinking corrosive products. So, there are a lot of other safety issues that we need to keep in mind as we move forward and get into some of the more sophisticated studies, like looking at indoor air quality and the effect of cleaning products on indoor air quality. So with that said, what I want to do today is propose a method for looking at the effect of cleaning products and cleaning processes on indoor air quality. Despite what I just said, I do believe that cleaning products can have a negative impact on indoor air quality. And one of the things that I want to do is really make that premise, to get all of you to hopefully agree with me that yes, indoor air quality or cleaning products can have a negative impact on indoor air quality. So once I get agreement on that premise, then there's a reason to go forward with a method, right? Then you have to have a method to saying, well, what do we do when we're trying to look at products and processes to assure that we minimize or mitigate that effect that cleaning products can have. So that's the start, is to set that up, to set the stage, to make that premise believable. And then we'll talk about, this is a methods paper. It's a methods development and proposing this method. And in order to do that, we did a pilot study first to determine product application rates. We'll talk more about that. It is a chamber study. That's the method Marilyn talked about yesterday, environmental chamber studies. And we'll describe that a little bit more. And in order to really determine whether or not something is safe, you have to have an indoor air quality benchmark. Then we'll show briefly a few results, and then also a little bit of discussion. So when I set out to put the presentation together, one of the first things I did was, well, what are all the chemicals that get out into the air when people clean? And Marilyn went through this nicely yesterday. I won't spend very much time on it at all, but not to anybody's surprise in this room, when you put products into the environment, no matter what state they have, no matter how you're applying them, they can put chemicals into the air: solvents, surfactants, acids, bases, fragrances, builders, et cetera, et cetera, et cetera. Marilyn did a good job presenting that. I won't linger there. So the next thing that I did for the presentation was, again, to get this premise together of, okay, I'm the one who wrote that fact sheet 10 years ago that said that cleaning products cause a VOC issue in homes or in the indoor environment. What is the actual literature out there right now? So I went to Medline and PubMed, which are free search engines where you find peer-reviewed scientific information on all sorts of topics. If you want to study cancer or asthma or anything. So I went to those search engines, which are sponsored by the government, and searched for anything I could find with cleaning products. And essentially, well, after doing enough of these searches, I compiled a nice bibliography of medical peer-reviewed publications looking at the impacts of cleaning products on human health. And I sort of divided those into two groups. There was essentially two groups. And some people here may disagree with this, but just for the purposes of getting through this, one of the groups was really what I would call an exposure survey. So in other words, somebody went into a building or a home and they took an air sample. And that could have been in a facility that was quote-unquote normal, or it could have been in a facility that was having problems, or it could have been while certain products were in use. But essentially, they went in and they collected an air sample. Now, as Marilyn said yesterday, if we took an air sample in here, we might find as many as 500 different chemicals in the air. Well, this shows you that there's a lot of chemicals in the air. Yeah. Now, is this causation that cleaning products cause these chemicals, or does it prove causation that the presence of these chemicals, or the presence of those 500 chemicals in the air here, is causing a health impact? No. No, it really doesn't do that. It falls short of doing that. It simply says, hey, as we're sitting here right now, all of us are breathing in up to 500 chemicals into our lungs. It's entering into our bloodstream, and maybe it's going to have an impact on us, maybe not. We don't really know. The second group of papers were epidemiological studies. Now, essentially, an epidemiological study is you're just taking two groups of people and you're studying the differences in those two groups. So if I take 100 people who are professional cleaners, and some of these studies are really, there's an active group in Spain publishing a lot of these studies, the Medina Ramon laboratory, and they're studying domestic cleaners in Spain. So if you take 100 cleaners, professional cleaners, and then take 100 people who are the same age, same sex, same socioeconomic status, same smoking status, same diet, and then if you look at those two groups, this 100 and this 100, how many of you have asthma? How many of you have asthma? How many times a day do you sneeze? How many times a day do you sneeze? What's your lung function, et cetera, et cetera, et cetera? And you do statistics on those two groups, and you have an epidemiological result. Well, there's a growing body of evidence suggesting that cleaning products can exacerbate respiratory conditions. And these studies are fairly recent, from 2002 to 2006, and there's an active group of people out there publishing more and more of these studies, looking at the impacts of cleaning products on health. Now, what these epidemiological studies tend to be hampered by lack of exposure. So yeah, this group of people, with this 100 cleaners, they clean. How much stuff are they breathing in? How many cleaning products, how much glycol ether or surfactant or solvent are they breathing in? We don't really know from these studies. So is this causation? Does this prove that cleaning products cause indoor air quality concerns or indoor air quality detriments, and that leads to human disease? No, this doesn't. This group of data doesn't do that. However, I think, again, trying to establish this premise that if you look at the body of evidence out there, you can come to the conclusion that the studies have raised questions about the impacts of cleaning on indoor air quality and respiratory health. We certainly can say that, I think, with a lot of confidence. So because of that, we want to develop a method to evaluate this, to really dig into it and look at this relationship between cleaning products and indoor air quality. So how are we going to do that? Now this is one method. I'm not saying that I'm, Mr. Method Development up here and I know everything, but this is a proposed method to do this that offers some very distinct advantages over other ways of getting at the same question. And the method essentially is to do chamber testing during cleaning. Okay, so what we're going to be talking about is recreating a commercial building cleaning process. And that's going to involve, so think about a casino. We're in Las Vegas with 1,000 rooms. And think about what happens when those rooms are clean. You have, as you're walking down the hall, you see the janitorial cart, and there's 4 trigger sprayers, on the janitorial cart. So you have multiple products being used. We don't just have one single product entering into this chamber to be studied. We have multiple products. We're trying to get as realistic to what's actually happening during cleaning as we possibly can. There's application in cleaning. I mentioned before about known problems, like if you take Dursban and saturate a carpet and just leave it sit there, you're going to cause a known problem. What happens if you mix bleach and ammonia? We still have that is still happening. That's another issue I didn't mention, but people are still doing that on a daily basis and getting hurt from it. So you have to take into account the process. You can't simply look at those 4 products and disregard how those products are going to be used. You have to take into consideration application. What is the cleaner actually, what is the person actually doing with those products? Are they standing back here and just spraying? Are they dumping it? Are they spraying the cloth, or are they spraying the mirror? How are they going about cleaning? So we need to specify that and incorporate it when we look at this question. We decided to use, for general purpose cleaning, to use the restroom as the model for chamber testing. And the reason for that is, you think of your hotel room, there's more surfaces in there to be cleaned than anywhere else. So the restroom was used as a surrogate because if you look at the amount of surface area to be cleaned per the amount of airspace, the restroom has the highest application of products. So that's where you'd want to start to look. And so essentially, again, this is a chamber test. To do this, to take air samples, and then to compare the results to indoor air quality benchmarks. Before we could get started with that, we had to really establish, again, to make this as realistic as possible, how much product does a person use? Now, you can look at the label. You can look at, there's some industry literature out there about how much product a person tends to use. But if you actually study it, you'll see some surprising results, or maybe not so surprising. But if you look at toilet bowl cleaning, for instance, I think it was 2.5 ounces is what our technical people within our company said, yeah, that's generally speaking what a person uses when they clean a toilet bowl, 2.5 ounces. But it ranges, a huge range, up to 6 or 8 ounces. Some people really, really like to use a lot of toilet bowl cleaner. So how do you incorporate that? To make this as real world as possible, how do you incorporate that variability into the study? Well, what you do is you do a pilot study, and you actually get volunteers to come in and clean a toilet bowl, and you measure before and after the weight of that container, and so now you know the volume of product they used, and you take the 95th percentile. So 95% of the people use less than that amount of toilet bowl cleaner. So that's how we establish the product application rates going into this the chamber to do the study. So we did that for all the products. So Marilyn showed a picture of it yesterday. I don't have a picture, but we had a mock bathroom set up in a stainless steel environmental chamber with the toilets and sinks, counters and mirrors to really recreate what a bathroom is like in terms of number of toilets per cubic meter of air, number of sinks, et cetera, et cetera. Again, trying to make this as close to real world as possible. And then we recognize that sometimes the cleaning happens with 4 products on the laundry cart. Sometimes it's 2. There's different combinations of how products could be used. So we recognize that, and with the 4 products we were interested in testing, we had 2 different scenarios that our customers could use when using the products. Again, trying to recreate reality as much as we possibly could. And then we had a trained technician clean the restroom according to our recommendations. And those recommendations were the real robust recommendations that we have a manual called Healthy High Performance Cleaning that really specifies. You spray the cloth, you don't spray the mirror, which can have an impact on indoor air quality. So really trying to nail things down as much as possible to have reproducibility within this environmental chamber test. So not only is it important for us to have that so we could look at different cleaning systems, one to the other, but as we're offering this out as a method, as other manufacturers can start to do this, we can have comparisons that way. So then sample time. So the products are applied in the bathroom as specified. Air sampling begins immediately and stops 48 hours later. And that air sampling is used to estimate concentrations of anything that's found in the air at 4 hours and 48 hours after application ceases. So then that data, those actual levels, so if there's X number of chemicals in the air, each chemical that's quantifiable, we have a part per million or a microgram per cubic meter concentration, and each one of them each concentration is compared with an indoor air quality benchmark, which is what we're proposing as the safe level for an indoor air quality contaminant. Some of the chemical classes that were analyzed in the environmental chambers: aldehydes, phthalates, all individual VOCs, and total VOCs just summed together. So indoor air quality benchmarks. This can be a pretty controversial subject, and as a toxicologist, it's something near and dear to me. Instead of having a toxicologist like myself spend a career developing an indoor air quality benchmark for everything, why not look at what's already been done? The ATSDR, or Agencies for Toxic Substances Disease Registry, which is part of the CDC, has minimum risk levels. They've Spent a lot of time developing those benchmarks. They're pretty well accepted. State of California, the United States EPA. We also looked at the American Conference of Governmental Industrial Hygienists for threshold limit values, occupational safety benchmarks. So what are the actual benchmarks? This was also presented by Marilyn yesterday. The short term of the 4-hour acute levels are printed here, and you can see that there's reference to the governmental agencies that have already established these things. In some cases, safety factors are built in where possible. Certainly there's a significant safety factor, one of 10% of the TLV, or 1/100th of the TLV for VOCs. So essentially we have validated indoor air quality benchmarks to compare against. So the results of this particular cleaning system, Marilyn mentioned this yesterday as well, but if you looked at the 4 chemical products, and if I asked one of our chemists how many raw materials are there in those 4 products, well, they would say there's 24. Total sum of that, we would expect there to be 24 chemicals that would appear in this chamber. Well, we actually found 51. So there was an additional subset of chemicals that were in these products that were either not disclosed to us or unknown to us, or maybe even unknown to the supplier. But even when you're purchasing high-grade chemicals for use in products, you still have other things that are coming along in that raw material stream. So that's, I think, one of the important results of this, as opposed to doing this on a paper exercise, that you would not appreciate the fact that there are some quote-unquote invisible chemicals until you start to do GCMS and other sophisticated analysis to shed some light on those issues. So the number of chemicals identified in the short term or the acute or the chronic levels that were on any of the lists for the California Prop 65, which is reproductive toxicants and carcinogens, at least those chemicals known to the state of California. US EPA carcinogens, ATSDR, minimum risk levels, or California acute or chronic recommended exposure limits. That's what a REL is. Whenever you get into the safety benchmarks, it's alphabet soup with acronyms. But we didn't find anything that were identified on those lists. So that was good news. Also, we did find one chemical identified in the 4-hour sample, or the acute sample, listed by the American Conference for Governmental Industrial Hygienists. And what they do is they establish TLVs, or threshold limit values, which is an 8-hour exposure period that a person could be exposed to in an occupational setting. And this chemical that we identified was 1,000-fold lower than that threshold limit value. As you remember from the other slide, it had to be 1/10 of that. So we have an additional 100-fold safety factor for the short-term chemicals found in this cleaning system. And for the 48-hour, the chronic, there was one chemical identified that had a TLV, and it was 10,000-fold lower than that TLV. If you remember, it had to be at least 1/100th of the TLV for the chronic. So that's essentially what we did. And in thinking about this, why is this method important? Why am I here right now talking to you about this method and trying to get you to believe that this was a good way of going about to look at a cleaning product system? Because right now, certainly formulators look at the impacts of their products before they put them out in the market. You're required to do that. But essentially, it's mostly done on paper. Essentially, what formulating companies do is they look at what are those chemicals, what do I know about those chemicals. Sometimes they do modeling. Sometimes they take those chemicals and make assumptions about how much is put into the environment and put it into a model, and derive a level in the air that they would expect to be associated with the use of that chemical. perfectly valid way of doing that, and I've actually published a paper using such a model in a way to show safety of products. But anytime you do modeling, there's a lot of assumptions that go into that model. This isn't a real world or as close to real world result as we can in a controlled chamber where you don't have a lot of variability going on around you. So there are some distinct advantages of doing this in an environmentally controlled chamber. It's an actual measurement of the airborne concentration. So you're not just modeling this. You're not just predicting this. You're not simply looking at the formula on a sheet of paper and saying, yeah, it complies with California's VOC laws, so therefore it must be safe for the indoor air. It goes above and beyond that. Products of chemical reactions between ingredients are discovered and quantitated. Marilyn talked about yesterday, terpenes like D-limonene and things in the air like ozone or hydroxyl radical react and create new chemicals that people are exposed to. Well, we didn't know about that till somebody did the study and identified it and brought it to light. So this type of an approach can identify novel products that can react. What happens if you have hydrogen peroxide and D-limonene reacting together? Do you create peroxides of limonene, which are potent sensitizers? So it actually looks at the impact of cleaning procedures, which is, again, it's very, very important. And this doesn't preclude anybody from doing something stupid. It's not the purpose of this. But at least it specifies when somebody does this the way they're supposed to, what's the result you get? What is the actual result in the air that a person is breathing in, and is it or isn't it safe? So it can also help you look at those procedures. Is there an impact of spraying on a cloth versus spraying the mirror? And you can start to look at things beyond the chemicals in the products, like tools. What impact do microfiber mops have? What impact do any tool that you want to investigate? So opportunities for further study. I think this method could be expanded upon. There's been a lot of talk about cleaning effectiveness. That wasn't the purpose of this method. It wasn't to look at, is that restroom being cleaned effectively? But it certainly could include that. You could preload the environmental chamber with some sort of soil, implement the same exact procedure, and then not only measure, is there anything happening on the negative side, but you could also measure what's happening on the positive side. So that's just one opportunity for further study. But to sort of wrap things up, again, this is a methods development paper. We feel like it's a very good way to go forward and to really start to dive into that question of what impacts do cleaning products have on indoor air quality, because it's not as clear when you really start to look at the published science out there in the peer-reviewed medical literature. I think it's not perfectly clear what is the impact of cleaning products on indoor air quality and human health. And what we're proposing today is one method to advance that science. I thank you for your time.